Hello everyone, welcome back to part 2 of our building a video compressor series here on Building with Easy. First off, I want to say a big thank you to everyone who watched and supported the first part of this series. If you are new here or just joining us now, make sure to check out part 1 where we introduced the project. We also walked through the tech stack and we also saw a live demo of how the final app will look. Before we jump into the code, I want to take a quick second to find out from you if you are enjoying this kind of content. Please don't forget to like this video, drop a comment below with any question or suggestions, share this video and my channel with anyone interested in learning real-world software engineering, and of course subscribe to Building with Easy and hit that notification bell so that you will never miss a new upload. Now let's dive into what we are going to cover in part 2. In this episode, we are going to start setting up the backend and front-end structure of our video compressor application using Spring Boot and Webpack. Here's exactly what we will be doing. The first thing we need to do is to create a Spring Boot project from scratch. So we will use starter.spring.io to bootstrap our backend and add all the necessary dependencies like Spring Web, WebSocket and more. We will then configure the application of properties files. We will set up some basic configuration to prepare our server for handling file uploads and real-time communication later on. Then after that, the next thing we need to do is to set up the package structure. So we need to organize our Java code by creating clean and scalable packages like controller, service config and more. Now the next thing we need to do is to run the backend application just to make sure everything compiles and runs without errors. After that, we'll start preparing the front-end folder structure. We will create a dedicated folder for our client-side implementation. Then the next thing we need to do is to build the front-end directory layout, including folders like public, JS and CSS to keep our assets organized. The next thing we need to do is to configure Webpack. This will help us bundle and manage our JavaScript and CSS files efficiently. So after that, we'll then initialize our package.json and package.log.json files. These are essential for managing our front-end dependencies and scripts. Then the next thing we need to do is to install all the necessary front-end dependencies such as Webpack, Webpack CLI and other tools we will need as we build out the UI. So after this, we will then create the HTML and CSS structure. We will write the basic HTML and CSS code for our video compressor interface and test it in the browser to make sure everything is connected properly. So whether you are brand new to Spring Boot, Webpack or full stack development, this part is packed with foundational knowledge that will set the stage for the rest of the series. Having said this, now let's get started. So now we come to start.spring.io where we are going to bootstrap a Spring Boot backend project. You can see we are using the Java programming language and then we are going to be using Maven as our build tool. We are going to select this version 3.4.6 and then the next thing we need to do is to set up our project metadata. We are going to specify the group, and this group is also known as the group ID. It is usually your company's name or your organization's domain name in reverse order. Alright, like for example, this is what we are going to be using. We're going to be specifying com.compressor app, alright, as our group ID. Then the next thing we need to specify is the artifact. The artifact is also known as the artifact ID, and this is the name of your application or your module. So for this application, we are just going to specify a video compressor. So that's simple. That's also the same thing we're going to specify as the name of the application. And then we're going to add a description. The description is straightforward. For the description, we can just say building a video compressor app. For the package name, we are going to specify the root package where our main application class will reside. And for this our application, we are going to have com.compressor.app as our package name. Then the packaging is going to determine how our application is packaged. All right. So we are going to use jar because jar is the default and it's good for standalone application. If you want to use WA, I think WA is mainly used when deploying to an external servlet container like Tomcat. Alright, but for this tutorial we are using jar. Then we are going to specify the Java version. So for me, I'm using Java 21. Java 21 is an LTS. Java 17 is also an LTS, depending on the Java version you have in your own machine. But for me, I'm using Java 21. The next thing we're going to be doing now is to add all the necessary dependencies that we'll be needing to build this application. All right, so I'm going to add all the dependencies, then I will explain each of them. Alright guys, so let's explain what these dependencies will do. So for this Spring Boot Dev Tools, it is going to, its main functionality is to enable automatic restart when your code changes. So you don't need to manually rerun your code each time, alright, or restart the server each time. So it improves our development speed with features like live reload, default caching, and enhanced logging for debugging. The next dependency we have here is Lombok. All right. So Lombok automatically generates boilerplate Java code such as a getter and setter method to string, equals, and hash code, and also constructors and builders and loggers. So Lombok makes your code cleaner, shorter, and easier to maintain. The next dependency we have here is Spring Web. This is a web application support, and what does it do? It allows you to build web applications and REST APIs. It handles HTTP requests and responses. And also, we are going to be needing it to create endpoints like /upload to receive video files and also return JSON responses for our front end. We are going to be using WebSocket for real-time communication. All right. It enables a two-way communication between the client, which is the browser, and the server using WebSocket protocol. So unlike regular HTTP requests that are one-off, WebSocket keeps a connection open so both sides can send messages anytime. So we are going to be using it to send the real-time update of our compression progress. All right. Now, the last dependency, we are going to add it in our pom.xml file, and it is called Java. All right. So Java stands for Java Audio Video Encoder. This library wraps around FFmpeg. It allows you to perform audio and video encoding tasks directly from Java code. So the Java all dependency version includes all native binaries for Windows, Linux, and macOS, so you don't have to install FFmpeg separately. We are going to be needing this particular dependency for our video compressor. So I'm going to add the dependency in our pom.xml. But first of all, we need to open this project in our IDE, and we are going to be using IntelliJ for this particular project. So now, after opening our project in IntelliJ, the first thing we need to do is to wait for the project to build. All right, you can see Maven is installing all the necessary wrappers and dependencies that this project will need application to run properly. Now that it is done installing, the next thing we need to do is to go to the pom.xml file, and then we need to add that Java dependency. All right, so after adding the Java dependency, we just rebuild to ensure that everything is in sync. And then after doing that, the first thing we need to do is to configure our server port. All right, so we want this application to be running on port 5050, and that is what we are going to specify here. So after specifying the server port, the next thing we want to do is to specify the access point of this application. The base URL, we want to set the base URL. So if we want to access this application, we want to be able to access it in something like http://localhost 5050, and that is what we are going to specify as the app base URL. So after specifying the base URL of this app, the next thing we want to specify is the app version. So this is version 1 of this application, and that is what we are going to specify here. And then after specifying the version of this app, the next thing is to specify the title. So, and the title is going to comprise of we are going to have something like API/version. All right, and then once we append this app.title to the base URL, we are going to have something like http://localhost 5050/API/v1. all right, so each time we create a new endpoint, so we are going to append the name of the endpoint to this particular address, which will be http://localhost 5050/API/v1/ the name of that endpoint, which might be something like upload. So after configuring the application or properties files, the next thing we need to do now is to create all the necessary packages that we will need for the backend. These packages will actually contain all the classes that we are going to be writing our code in. We are going to create packages such as config, controller, exception, response package, and then we also create a package that will contain all our business logic, and we are going to call that package service. So after creating the package, the next thing we need to do is to run this application to be sure that there is no error anywhere. All right, you see the app has built successfully, and the app is running on port 5050 as we specified in the application.properties file. So the next thing we need to do now is to create a folder. All right, so we are going to create a folder that will contain our front-end project. So after creating that folder, we are going to open the folder in our VS Code, because we are going to be using VS Code to write our front-end implementations. So after opening the application in VS Code, the next thing we need to do is to create different folders, all right, that will contain our front-end implementation. So the first folder we are going to create is the public folder. All right, so after creating the public folder, we will then create our webpack file, and the webpack file, as we have mentioned earlier, is going to be in charge of bundling and handling all the resources that we will need be needing to run the front-end app properly. So after creating the webpack file, so the next thing we need to do, let's just create a folder for our CSS for the JS file, and also let's create an index.html file. Now in the webpack config, we are going to have some configurations, all right, that will actually need to build our front-end files properly. We are going to need to specify the entry points of the application in the front end. So I'm going to quickly implement the configuration, all right. So when I'm done, then I will now explain step by step what is going on. Look at this first line now, all right. So this imports the watch function from Node.js built-in file system module, all right. And then this compass, this also imports the built-in Node.js path module, and we are going to use it to construct file paths in a way that works across different operating system. Then this module.export, so this is how we are defining and exporting the configuration object for webpack, all right, to use in our system. And then we have set the build mode to development, all right, because we are still in development mode. This will enable us to build our app faster, all right. And then this is the entry point, and this defines the starting point of our application. So yeah, webpack will start bundling our application from ./public/js/app.js. Now this is our output file, and this will tell webpack where to output the final bundled file, all right. So for our project, we are using the public/dist, all right. So our final output file will be available in our dist folder. So now finally we have this watch. We are setting watch to true, and what it does is that it will enable webpack to automatically rerun when it detects a change in our source files, all right, like our app.js or any other imported files. So after configuring the webpack, the next thing is to create our package.json file, all right. So we need to initialize our package.json file. So the program is going to guide you through the creation of the package name, the description, the entry point, and other details that might be required, all right. So it is pretty straightforward. So and when you are done, you just click on, just type yes. So and now you can see that the package.json file has been created. So the next thing we need to do is to install some of the necessary dependencies that we'll be needing. So first of all, we're going to do npm install. Before then, we want to specify webpack in our package.json file, all right. So in this script session, we are going to specify the build as webpack. So after that, we will then run this command to actually install our webpack. After installing our webpack, we want to run a command. We'll say npm run build, all right. Okay, I think we have an error. Now what we have to do is that we just need to create app.js because it's not existing present. We'll just create it in our JS folder because webpack cannot find it. That's why it's giving us this error. So after creating it, we will now run npm run build again, and then as you can see here, the build process is successful, and you can also see that a dist folder has been automatically generated for us. The next thing we need to do is to quickly add our HTML and CSS code. So I'm not going to be typing out the HTML just to save time. So I'm just going to copy the HTML and paste it, and I will also do the same for the CSS. All right, so I've pasted the HTML right here, and I've also pasted the code for the CSS. All right, so you can see it is very simple. There is nothing much here. So after pasting the CSS, let's connect the HTML to the CSS. So we are linking it in the header section. All right, so the HTML and the CSS code will be in my GitHub repository. So I will encourage you to go to my GitHub repository, clone the application, then get the HTML and CSS file. All right, and then add it to your own project setup so that you'll be able to follow along the tutorial. So now let's try to access the app in the browser to see what we actually have, whether there is any error. All right, we just need to make sure that there is no error and that everything has gone as it is supposed to. So as you can see, we have actually accessed the app. So this is the UI of the application. All right, and that is it for part 2 of our video compression app series. So we successfully set up our Spring Boot backend. We configured the application, the properties files, and we also created a clean package structure. We also initialized our front-end folder and got webpack up and running with a basic HTML and CSS setup. So if you have followed along and got everything working, great job. So if no worries, drop a comment below and I will help you get unstuck. Before you go, hit the like button. If this video helped you out, drop any questions or feedback in the comments. Share this video with anyone who wants to learn how to build a real-world application with Spring Boot and Webpack. And of course, subscribe to Building with AZ and turn on the notification bell so you never miss a new upload. In part 3, we are going to take things even further by creating our WebSocket configuration. So we are going to be doing most of the backend implementations in the next part. We will also be setting a real-time communication between the front end and the back end, and we'll also be preparing the foundation for sending live compression updates from the server to the browser. So if you are excited to see how we are going to make the app feel more responsive and interactive, don't miss part 3. Thank you so much for watching and supporting this channel. I really appreciate you guys. I'll see you in the next one. Keep building.